In a previous video, we discussed computational thinking with James Larus, full professor and dean of the IC School at EPFL. TLDR, computational thinking is not about programming. Computational thinking is about applying concepts from computer science like algorithms, computability, or scalability to all sorts of problems.
Unless you took a course in computer science in the last few years, you haven't seen this before, because this is not something that you would have encountered in your education. It's not something that typically people who are, even have PhDs and do research, or professors in other fields have learned, because, it's a relatively new set of tools. We've developed them over the past, I'd say 30, 40 years, and, computer scientists have sort of made them, demonstrated their value, demonstrated their utility. And now we've started to work with other disciplines, and we've seen that they're very applicable to solving problems in many other parts of the world as well. And so we've started to now reach out beyond just our colleagues as PhD level researchers and say that maybe these are skills that everybody should have.
However, teaching computational thinking on a large scale poses big and difficult problems.
One of the big problems is that you have to find the teachers for it. So, we teach it here in computer science because we're full of computer scientists. But, if you wanted to go and teach it in the Swiss high schools, which is, one of Martin Vetterli's, our new president's, goals, how do we find teachers in high schools who know about this? So we have to first educate the high school teachers and teach them what is computational thinking, and have them really understand it at a fairly deep level and have good examples for the students before they can teach the students. So there are a lot of challenges, as with any new field. It's this bootstrapping process. You have to sort of produce the people who sort of are capable of teaching it before you can teach it on a widespread way.
But if finding teachers to teach computational thinking is so hard, doesn't this mean that computational thinking might be too hard for high school students?
It's something that can be explained very easily to students. You can come up with examples that they're very familiar with. You can have them try to solve the examples. You can analyze them. You can really sort of make it very tangible to the students. So I don't think it's a difficult subject to get into, even the gymnase level in Switzerland. And certainly at the EPFL level, we make all of our students take ICC the first year, which introduces them to these ideas. And so, all the students at EPFL have the necessary background to understand these ideas and to apply them in their own disciplines.
It seems that the need and the desire to teach computational thinking is growing years after years. But how do we make this a reality?
There isn't yet a strategy. There's a big effort to come up with a strategy. So we're working on it at the EPFL level. ICC was first started about 3 or 4 years ago. It's become sort of a better and better course every year. It will become a more important course for the first year students, and there will be follow-on courses in other fields sort of emphasizing this idea of computational thinking. The Vice President for Academic Affairs, Pierre van der Geest, is very much pushing this direction. We're also talking to the cantonal administration about what it will take to get these ideas into the gymnase level in Switzerland. Who will teach it? Where will the time come to teach it? How do we educate the educators? And then there is also the third part, which is what do we do about teaching the rest of the Swiss, the people who are finished school? How do we, teach them about these ideas? And, possibly the MOOCs. We don't really know how that's going to happen yet. But yes, there isn't a specific plan, but there's a lot of interest in it. And this is one of Martin Vetterli's priorities.
And what we tell our children about computing, we've ended up focusing too much on technology, on things, on devices, on those seductive boxes, and not enough on ideas.
I think that computer science should be taught as an intellectual discipline with some sort of very powerful ideas in it. And then you should be also taught programming as a way of applying these ideas.